Awesome. Okay, so I'm in my meet. Oh, and there was one other thing I wanted to brag about one of my kids before we start today. Sorry. Oh, where is it? I'm going to go back to our book. On page 207 from yesterday's homework. No, it was on page 206 from Tuesday's homework. Somebody blew my hair back. I am not kidding. Okay, so are you guys ready for this? I hope you're ready for this because maybe, just maybe, it's going to blow your hair back too. Okay, so remember yesterday we were talking about how to solve questions 1, 2, and 3? Okay. Here is what one of my little angels did to solve those questions. Well, of course, number 1, what percent of the students answered salad? Well, there were 10 students, okay? And I believe that child said, oh, okay, so if there's 10 students out of 40, that's equal to 1/4, and I know 1/4 is 25%, okay? So they knew this answer, okay? And they knew the pizza was 30%, so they basically thought to themselves, okay, well, if this is 25% and this is 30%, do I have to do anything really other than find the missing number from 100 here? Okay, are you ready? Because you might be a little confused still. Here's what they did. They took the percents that they knew about, the 30% who ordered pizza, or like pizza as their favorite food, the 25% that liked salad, and they got 55. 55% of the kids like pizza and salad. So then they deducted from the 100, because how much is a percent per 100, right? They deducted that 55 from there. And lo and behold, they were able to solve for the percent of kids who liked pasta. How intelligent and bright is that? Dear me, oh my. I was like, she did what? I can't even believe it. But that actually works really well too, doesn't it? Okay, mind blown. All right. So that was a really cool thing to see. I love to see when people are thinking differently from me because it makes my hair blow back. I tell you what. Oh, man. Did it give you guys shivers, like little goosebumps and stuff?
Almost.
Okay, well. All right. Whew, I gotta breathe. Okay, ladies and gentlemen, I'm still unmuted. Wow, okay, so we have this done, right? So what was this blank here, everybody? Numbers. What's this blank, everybody? Operations. What's this word? Variables. What's this word? Terms. These are terms, okay? And now, since you have those blanks filled in, I don't remember if we did this yesterday or not, so we're going to just go ahead and do it. What is the coefficient of 5p plus 4? Get your pencils ready. What is the coefficient? The coefficient is the number that hangs out with the letter. It is only 5. The coefficient is the number that hangs out with a letter. Okay? What is the variable? P. What is the constant? 4. And then you just write out the terms with a comma in between. Here's what we do to identify our terms. Okay? So hopefully you've got those notes down. Okay? Just write them down on your notes. This is not for your dry erase marker. I said pick up your pencil. Okay. And before we move to the next box on our notes, I want you to add another little bit of notes. So, and it goes along with this little sticky note here. Okay. So this little bit of notes, I want you to write a new expression. I want you to write like a minus 7. Okay. Just write the expression a minus 7. I just dreamt that expression up and I have nothing to connect it to in the real world. Okay, but let's read what the sticky note says. A variable all by itself has a coefficient of 1. Okay? So even that A has a coefficient, even though there's no number standing there. Okay? If a letter is hanging out all by itself, if the letter is all by itself, it still has a coefficient of 1. So I could actually say that this expression is equal to that expression. Okay? So I want you to know that that's super important. Okay? So if I asked you what is the coefficient of A minus 7, the coefficient is 1. Capiche? Very good. Okay? So that is written in our notes now. If you're thinking about what that means anytime we see a letter hanging out all by its own self, a letter in an expression or equation all by its own self means that the coefficient is 1. Okay? And I think we got everything on this page that we needed. I think that we talked about how initially 7n is an expression that we can call the age of a dog in the old way to do it, right? 7 years for every number of years the actual dog years the dog has been alive in human years. Okay, but there's one other thing I want to mention about this. Okay, so if I want to really think about 7n, I have to remind myself, since there is no this or this or this or this there, what does it automatically refer to? If there is no symbol saying whether we're adding, subtracting, multiplying, or dividing, it's just a letter standing next to a number. What does that mean, everybody? Multiply. Anytime a number is just standing beside a letter and they forgot to put any adding, subtracting, or multiplying or dividing signs next to it, please just multiply. As a matter of fact, mathematicians are inherently lazy, and they've all decided that anytime you have a number next to a variable, it's just automatically multiplication. Okay? So, right now, what I'd like you to do is using that expression, if you have a dog, talk to your neighbor and tell them how old your dog is. I'm going to remind you how old Lady is before I tell you to do this. Okay, Lady, I can't spell, evidently. Shh. Lady is 5 human years old. Okay, so that means I have 7n. 7 times 5 means that Lady is 35 years old, right? Okay, so now talk to a neighbor about how old your dog is in dog years. And if you don't have a dog, listen to your neighbor. So 7 times 2 is 14. So 12 human years? So 7 times 12 is? I don't have it all. My dog's 8 weeks old. Oh, I'm talking to Danny. Sorry. 8 weeks. You'll have to do some definite figuring there. Okay, class. Okay, my turn to talk. Everybody's turn to listen. Okay, let's wrap it together again here and finish up your conversation. We're going to go ahead and move on. All right, kind of. I'm really stuck on this whole talking about dogs and age thing this week. I don't know what's wrong with me. All right. So you remember that I talked about there being other ways to calculate the age of a dog. And the one way that I found in the American Kennel Society was too difficult because you have to know how to deal with logarithms and simple things like that. So we don't want to do that because we're not quite to calculus yet. Okay. So the other way to solve for the age of your dog is to use the rule of thumb. You do not have this on your paper, but yesterday I did ask you to write this expression down, right? It says the following rule of thumb is a useful way to compare the age of an adult dog with the age of a human. Call the dog's age in dog years. Multiply the dog's age by 4. We decided we'd call the variable there the y. And then add 15. Sorry, I shouldn't have put that there. And then add 15. I had to erase my multiplication sign because did I need a multiplication sign between the 4 and the y? No. If you have a number that's going to be multiplied to a variable, you just stick that number and variable side by side and boom, you're good. So that's the expression. So as an example, if Lady, again, she's still 5, is 5, I would go 4, 5, 15, and then I'd add 45 plus 15, right? Who said no? Thank you, Brody. Okay, I saw a lot of this going on in our homework assignment. I saw a lot of people just putting the variable number. See, Lady is 5 years old, right? I saw them just making the number 45 and not multiplying the numbers together. Okay, you can't do that. You can't just say, oh, 4y must mean 45. It does not mean that. It means 4 times 5. So 4y plus 15 is actually 4 times 5 plus 15. So 20. Was it plus 15 or plus 12? It is plus 15. Very good. So 35. So don't make that mistake. But do this, use this expression, and then talk to your neighbor again about this different way to solve for the age of the dog and compare and contrast. I'll mute again, and you guys can solve again and then visit. Yeah. Okay. And that's a little different than the other way of calculating, isn't it? It's a little more, isn't it?
I don't know if I did it right, but it's 75 and a half. I think I did it right, but I don't know.
It was right. Class?
Yes, yes.
Oh, you guys got to do it louder than that. Class?
Yes, yes.
Beautiful. Now we're ready to get rocking and rolling again. I just have to get these guys quieted down now. Okay, let's pull it back together. And then I will go ahead and move forward again. All right. Still, we don't need to be using our markers unless we were solving for our dog's age on our dry erase marker board. But I really wanted that information somewhere on here. So if you did that on your dry erase thing, please just put it here with your pencil, okay? I don't want you to leave that somewhere off in dry eraserville and not in your notes. Okay, we filled this out yesterday, right?
Yeah.
So double check and make sure yours is filled out. If it is not, right now, in a super silent, quiet voice, look at one of your friends and say, hey, can I borrow your paper later so I understand how to do this? Try to do it on your own and then check your work with a good trusted neighbor because I don't want this to be left blank if you were absent yesterday, okay? Then we did these questions together on the board. How many of you have answered all of these on this next slide in your notes? Okay, so if you haven't, I want your pencils ready. If you have, just sit and pay attention for just a minute. Okay, z squared plus 9z. Z squared plus 9z. Here's what I want you to do. I want you to tell me what are the terms. Okay, what are the constants? And what are the coefficients? Here I go again. C-O-E-F. Someday I'll learn how to spell this word. Okay, so for this guy right here, the terms are what? Well, the answer there is going to be z squared and 9z. Okay. What are the constants? Bah! There are none. Don't put 0 there because 0 is a number. Just write none. There are no constants in that particular expression. And what are the coefficients? Just the 9. You might be tempted to put that square there, but it is not a coefficient. It means the square of a base, and that has nothing to do with being a coefficient. Okay, so don't put a 2 and a 9 there. Okay, so in your notes, you need to write that down. Awesome. Okay, now you can do this. On this particular one, we can say the same thing. We can say, well, what are the terms for 15 plus 3y plus 1/2? And I've done this, I don't know how many times for this particular one, but we'll do it again. Those are the terms. The constants are the 15 and the number 1/2. And the coefficient, in this case, is just that 3 hanging out with the W. Coefficient means I'm a number that is hanging out with a letter. Okay? Beauty. Get that written down if you haven't already. And that goes with this guy right here, doesn't it? Okay? And then this guy, what can we call him? We can call him 12, but he is a constant. These two are terms. This is one of the terms. This is another term. Okay? And this dude here that's hanging out with the letter is a okay? So if you don't remember how to spell those words, you better start remembering because Mrs. Franzen soon is going to learn how to spell too. Okay? So it doesn't have to be exactly like mine. You could have done yours a little differently, but let's not rely on Mrs. Franzen remembering stars, circles, and underlines. I just used that first day to get us ready to be talking about those words, those vocabulary words. Okay? And okay, there's still people writing in my room, so I'm going to give you a little bit more time. And then, of course, you're going to be turning your page.
Which one?
Turn your page when you're done. this already. We're still not using those markers yet. I should have waited to hand out the markers, I think. Okay. So we have our terms, our constants, and our variables all identified there. I forgot to tell you to identify the variables, but we remember what the variables are there, right? Variable is here is C, the variable here is W, the variable here is Z. Okay. Let's go ahead and move to the next page like I promised, because I kind of am jumping around. Sorry about that. Write these expressions using exponents. Some of you did this already yesterday. Remember, the x's just symbolize multiplication. Okay, 9k to the 6th. And the j, how many j's were there? There were only 5 k's? Oh, my bad. Sorry about that. I lied to you guys. I do not enjoy lying to you guys, but it looked the same length as all the j's in a row, so I assumed they were both 6's. Okay, are you done writing that down?
Oh yeah, I'm still.
Okay. And next slide. Evaluating 24 plus C. We did this on our dry erase boards yesterday. Take a moment to do it on your paper if you haven't already. Okay? So take a moment and do it on your paper if you haven't already. So they told you that the C's value is 9. Okay? And yesterday, several people told me this was the answer. So the answer to that expression is 33. Okay? And for some reason, Mrs. Franzen also gave you the same exact expression on the very next slide, because I wasn't paying attention when I was building your notes. All right, so right here is the same exact expression, isn't it? Okay, so we could just put a 33 here on that next slide. What?
It's not 33.
It's 33. You just missed it by 1, sweetie. Thanks for disagreeing respectfully, though. Okay, that happens. All right. Now I have D minus 17. They told me that my D value is 30. So I take and I subtract.
It's 13.
23.
Somebody told me 23, but I really think it's.
Yeah, I think 13.
Yeah, I said 13. Yeah, it's 13.
Yeah,
See, that happens, doesn't it? You guys, it's okay to be wrong once in a while. And we're being nice to each other when we discuss a mistake like that, right? Because those are opportunities to learn. Hey. And that way, when Mrs. Franzen makes mistakes and you guys correct me, I don't cry in my closet. I haven't done that yet this year once. Hey, quit laughing. I've done it. I cried in my closet. You ask any teacher in the whole world, they'll tell you. I'll tell you once in a while. You just have to go to your closet, do a little crying. Okay, P times Q. P times Q. We solved this one yesterday as well. Yes, 192. P minus Q. Some of you wrote this down yesterday.
16.
Okay. And then we have one more slide. Once you're done, turn your paper over.
This one, right? This one?
Yep.
I'm trying to.
All right. Some of you may have written this down too. Remember, this was the tricky one. 30 minus 24 divided by y, and y's value is 6. we had to follow PEMDAS, so we had to do this part of the question first, didn't we? Okay, so we had 30, and from that we subtracted 4, and we got 26. Very good. No, it wasn't that one we got confused on. It was the one having to do with a 1/2 in it. Remember that? We were forgetting to keep change flip.
I did that for the first step.
Okay, since this y is still worth 6, it's still telling us it's worth 6. I have 6 squared minus 7.
Yeah, 29.
Yeah, if you don't multiply by
Okay, we had to square the 6. 6 squared is not 12. You never multiply the base times an exponent. You multiply the base the number of times the exponent tells you to itself. So that is really 6 times 6. Got it? Okay. So now that we've finished that, we went over finding perimeter and finding area. Okay, I'm going to toggle back to our math book. And we're going to talk a little bit. Okay. Exit. I want to go to my math book. I want to change my page. So our homework assignment was on the very next page, 207. Very good. And remember, you were supposed to staple yesterday's work to Monday's work before you turned it in, right? Okay, so I certainly hope you've done that already. If you haven't, please remember to do it when we're done doing the lecture today. All right, 21, perimeter. You can use the expression 2L plus 2W to find the perimeter of a rectangle, where L is the length and W is the width. Whew, that sounds terribly hard, but it isn't. Sorry for screaming in the computer. I didn't mean to. It was just like, woo. Anyways, it tells us then to identify the terms and coefficients and constants in the expression. Almost everybody whose paper I got yesterday, already finished, got that right for A. For B, they were very confused, and some of them just skipped answering it. B says, interpret the coefficient of the terms. Okay, another way to say that, maybe a little more 6th grade language, would be, why did they pick 2 for the coefficients? Okay, that's the same exact question. Why did they pick 2 for the coefficients? Well, they picked 2 because how many lengths are there on a rectangle?
2.
There's 2 of them. And they also picked 2 for the width because how many widths are there on a triangle?
2.
Yeah, because there are 4 sides on a triangle. They had to pick the coefficient 2 for each of them so that they had both of them represented in the expression. Okay, so when... Shh. Did I say triangle?
Yes.
My bad. Please don't listen to what I say, but listen to what I mean. Awesome. I know that's very confusing. Phew. Okay, so we're back to square one again. I would like to toggle over to a different screen because I'm thinking I must have forgotten to put something in here. Yeah, okay. So I have to switch over to a different slideshow. All right, you guys have been very patient with me. Each day I've talked and you're probably thinking, wah, 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 wah. Okay, I hope you're learning still, even though I'm doing a lot of talking. This is not my usual strategy for teaching. Okay. All right, here's where I want to be. Are we ready? I think we are. Please tell me I have these slides in here and I just put them in the wrong spot because I did mean to put them in a different spot. And I was working on this last night at home. It doesn't look like it's done. I've got that. Please tell me I have the other parts. Evaluate expression. I must have took it out of there. Okay, I went on a big long rant and I put down this, oh, here it is. Boom, found it. That's the question we just went over, isn't it? Okay, here's my rant. Are you ready for my rant? All right, it is written in ink up there too. It is okay to check the back of your textbook if you're unsure of how to answer a question like this, okay? I know it feels like cheating, but if you've done your level best at understanding how to answer your problem, it's okay to check. In fact, are you ready for this part? Because this is the important part. In fact, we would all get half of our answers correct if we just double check our work in the back of the book before we turn it in, right? That would be the responsible thing to do. That is not cheating. If you see that you are correct, or if you see that you are incorrect with one of the odd questions, then you probably should reflect on the even questions as well. Because if you've gotten the odd ones wrong, do you suppose you might have done the same thing wrong with the even numbers? Yeah. Okay, so that is a way to check to see if you're following the strategies and doing things right, is by double checking to see if your answers are right in the back of the book. So is it cheating to go to the back of the book? No. Would it be cheating to copy exactly this answer onto your paper? Yes, you would want to write that in your own words. Instead of saying exactly what the textbook says, show me that you've digested the fact that there's two lengths and two widths in a rectangle and say it in a different way, okay? So we've talked about using part of the question to answer the question and all the kinds of things you do to give me a complete sentence. So that's exactly the same kind of stuff you would do there. Again, we got to number 29 and some of us were completely kerfuffled, which is okay because have we talked about any formulas yet this year very often? No. Now, I really didn't talk much about the fact that the side length of a square is going to be the same for all four sides. But do we just know that intuitively? By the time we're in 6th grade, we know a square has to have equal sides. So they asked us to tell them, well, can you write an expression? So why did they choose 2D squared? Well, that's because for the area of a rectangle, you multiply the length times the width. Well, in a square, isn't the length going to be the same as the width? Okay, so you can just multiply the length times the width, and that's the same as saying square. Anytime you multiply a number times its own self, it's squaring itself. So that's why they chose that. Okay, so thinking a little more deeply there. And then some of us did really well on these. Most of us kind of struggled. No, I would say about half and half here. All they're saying in these questions is if your x value is 3, what would it be here? 3 times 8 is 24. If your x value is 6, just plug it in, and so on and so forth. So that's how those work. And now we're on this spot. Now we're going to go ahead and start thinking about using what we know about expressions to solve problems. So we're going to look at a few. Hey. So if I have an equation model, I can do it like this. You guys are going to be blown away. Are you ready? You might even want to hold on to maybe sit on your hands so you're not blown away and your hands don't fly up and hit your neighbors. Okay, listen carefully. Tina has 16 cousins, which is 7 more than Pedro. If you were to write an expression, you could use n to find the number of cousins Pedro has. Solution. Number of Pedro's cousins plus 7 equals number of Tina's cousins. Do you see what they did there? They stole out of the question and they used words to kind of put in the place with the operating symbols and the equal sign, right? And then they gave the things that need variables, and the things that had numbers already, numbers. So they knew that they didn't know Pedro's number of cousins, did they? But they did know Tina has 16 of them, 16 cousins, and that she has 7 more than Pedro. So n plus 7 equals 16. That's how they decided that. Okay, I want you to try this one. Try try this one on your white dry erase marker board. After Chan spent $11 for video rentals, he had 15 in his wallet. Please try to write an equation you could use to find why the amount of money in Chan's wallet before he rented the videos. Okay. Okay, this isn't time to talk, it's just time to write on your dry erase board. Chan spent $11 for video rentals. He had $15 in his wallet. Write an equation you could use to find why, the amount of money in Chan's wallet before he rented the videos. I don't know anybody named Chan, do you guys? Okay, does somebody want to share their answer with Mrs. Franzen? Miss Thiessen? Oh, she's saying $26. Beauty, okay. So how many of you agree with that? Okay, but can we write an expression? That's really what we're trying to do here, is write an expression. Okay, who can give me an expression? Carson? So 11 plus y equals 26? Oh, so you said y equals 15? Interesting. You know, I can't say that that's wrong. Okay, because that isn't an expression though. What we did here is we found an equation. Okay, so that's good. That's good. Any other thinking out there in math land other than in my classroom? Oh, okay. Well, she said y equals 11 plus 15. Okay, I'm going to just circle this here because I'm thinking we don't know how much money he had in his wallet before. Okay. Okay. So say your expression again. Oh, they're going to give us one.
I have an idea from Francis round.
Okay.
So first you do y minus 11 equals $15, but then you have to figure out what y is. So you do 15 plus 11 equals y to get your answer of 26.
I love it. Who is this? That's great. It's exactly what I was looking for.
Zeta.
Thank you, Zeta. Okay, she looked at that cue, the before word, and she said y minus 11 equals 15. Do you see why I really couldn't argue with y 11 plus y equals 26? I really couldn't argue with that. But again, I have to say that this keyword before tells me that Zeta's answer is more correct, but they both tell us that there was $26 in his wallet beforehand. Okay, let's move on. What do we have next? How much time do we have left? I've been yammering for a long time. 9 minutes? Lordy, lordy.
No, 9:51 again.
Okay. Okay, so I think I'm going to just go ahead and I don't know why all of these are blank. Let's look at this one. Let's try this. Use your dry erase markers, please. Try to write an expression that would represent these words and numbers. If I have 132 is 11 times number x. What would our expression be? Use your dry erase board. Show me what it should be. Well, 132 is 11 times a number x. It is not okay to blurt out questions without reading ahead. Or blurt out answers. Okay? Here's what I'm seeing. I'm seeing this. I see people saying 132. They use this word to cue them in that there was an equal sign there. And then 11 with an X right beside it. Okay? I've also seen people doing this. 132 equals 11 times X. Okay? Do we have to have that multiplication sign in there? No. Is it wrong to put it there? No. But it's way more work than mathematicians use to represent that there is a coefficient. Okay? Erase and try this one. Okay, these will help you if doing these and seeing how they're done will help you with today's homework. So please try this one. Okay, you're not solving these, you're just writing the expression, okay? Oh, I love it. I love that some of us are comfortable with the fact that we can do this. Can we do this? Did some of us do this? Okay, let's think about it. 3 is equal to a number z divided by 13. Did I write the 13 in the right spot?
Yes.
Careful.
No. Yes, reverse.
Yeah, you've got to be careful, guys. That's super important. The divided by means that he is the divisor. If you're ever, if you're ever wondering what to do there, you can always write it as a fraction because some people remember with fractions, the top number goes into the division bar. The bottom number is always your divisor. So the divided by could be here, and you could write it like that. Okay? And I love the fact that we know an equal sign does not have to be at the end with the answer behind it. I love that we feel like we're fluid enough with equal signs that we can have our answer in front, equal signs, and then the problem in the back like that. That's pretty cool for 6th graders to be comfortable with that, and I saw that all over the room. Okay? All right, beautiful. This one, I don't know why it's not, oh, it's because I don't have it in present mode. Okay, 9 times the number y is 36. Give that one a shot. Ooh, that's not quite. You have an exponent, and it's not an exponent. Close, yeah, close. Okay. Oh my goodness. This is great, you guys. Not quite. We're almost there. Okay. So if I have an is right here, can I put this here? And then I can put 9 times y. Yep, so I've been seeing 9y equals 36, and that is correct. I've seen 36 equals 9 times y. I've seen 36 equals 9y. All of those are right. Just remember though, ladies and gentlemen, if you have a number multiplied to a letter, we don't necessarily have to use that multiplication sign. 9y still means 9 times y. Okay? All right. We're going to do one more, and then I'm going to give you that last screen so we can get going here to our next class because I'm running out of time again. How about this one? This is easy. Do we need an equal sign in this one?
No.
No? Yep. Very good. Very good. Good, good, good. Yep. 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 Okay, there was only one mistake, and this would be common, okay? I had someone say this, okay? That means 4 times B. Okay, anytime the letter's standing next to the number, it means multiply. So we have to do this or this. Both of these would be correct. But we can never leave out an adding sign. The plus sign has to be there, okay? All right. Very, 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 very good, you guys. I'm so proud of you. Now, today's homework assignment is shorter, but there's some more thinking going on in it, okay? There's some story problems. I'm going to want to see some use of expressions to solve these few questions. Okay, your job is to do questions 51 through 65 on page 208 as homework. Okay? Again, don't forget, I have that phone number that you can send questions to. Text me your questions if you're at home and struggling. Let's have a fantastic day, you guys.
Okay.